Hi everyone. In this example, I want to get into a problem that's a little more similar to what you'll be running into most of on your homework. This one ties together a whole bunch of the things. So it has the symmetry, it has the definitions of the trig functions. So it's a pretty nice one. It has the given x or a y value or a tangent or a cotangent. Can you find all the other values? So lots of stuff tied together here. Okay, so let me start with the unit circle. See if we cannot make too much of a mess out of this thing. So, sorry, very crooked as usual. The information we're given is that sine of A is equal to 2/3, so that's towards the top of the circle. And A is between pi over 2 and pi. So we're looking for, there's two possible points with the y-coordinate of 2/3. We're specifically looking for the one in quadrant 3. So this is back to that whole thing where given a y-coordinate, there are two possible locations. If you really want just one, you need a little bit more information. The very first thing we're supposed to find is cosine of A, which would be the x-coordinate of this point. So given a y-coordinate, if you want to find an x-coordinate, you have to use our trusty relationship between x and y, which is x squared plus y squared equals 1. And we already know that y is 2/3. So we'll end up saying x squared plus 4/9 is equal to 1, which means x squared is 5/9. Again, there we would just get a common denominator. We'd say a 1 is the same as a 9 over 9 and then subtract. And then we can square root it. So x is equal to plus or minus √5 over 3. Because we're in quadrant 3, we'll want that negative √5 over 3. So to answer my very first question, the value of cosine is negative √5 over 3. And I can now label this point. It's a negative √5 over 3 2/3. Well, let me think about this. A √5 is a little, actually it should be slightly toward the bottom of my circle. Negative √5. So √5 is a little bigger than 2, which means our x-coordinate is a little bigger compared to our y-coordinate, so it should push us down here. I'm actually going to do it because with symmetry, you don't really want your point to look like it's anywhere close to the middle, so just pretend. That's a little exaggerated. But that's one of my biggest tips. If you're drawing this yourself, I would rather you be slightly wrong on where your point is to make it look a little further from pi over 4. If it looks like it's at pi over 4, it's really hard to see some of the symmetries. Are you getting symmetry across x or y equals x, or what's going on? Okay, and then A is the arc length that lands us at that point, and it's specifically the one between pi over 2 and pi, so that's going to be this distance right here is A. Okay, the next thing we're supposed to find is the tangent of pi plus A. So what we're going to need to do here is first figure out where we are in the unit circle. And then we'll want to figure out what our x and y coordinates are, and then we can calculate tangent. So we have pi plus a. So you could think about that if you wanted as a plus pi, that's the same thing. And that would mean we go a, and then we go an additional pi, which is halfway around the circle. So it puts us kind of out here. Again, I'm exaggerating a little bit how close we are to the x-axis. So exactly halfway across the circle, that would require a flip across y and x. So you can also think about this as, let me draw the triangle. If we add pi, we've rotated halfway around. So there's our original xy triangle. And if we rotate halfway around, that ends up right here. So the y has the, did I get halfway around? Yes, I did. Okay, sorry. It looked weird for a second. Our x is exactly the same size, but it's now the opposite sign. So it's going to be a positive √5 over 3. And our y is also the exact same size with the opposite sign, so a negative 2/3. And what we wanted to know about that point, so this is at the end of pi plus a lands there. So that's pi plus a. I'm not going to draw it in because it's getting a little messy already. We wanted to know about tangent, so we want to know what happens when we divide negative 2/3 by root 5 over 3. To divide by root 5 over 3, we actually want to multiply by 3 over root 5, so the 3's will cancel, and we're going to get a negative 2 over root 5. Okay, so figure out where you are on the unit circle, figure out your coordinates, and then find the value of whichever trig function you're being asked about. Let's see, let's do green. Secant of the opposite of A. Okay, so A was not quite halfway around, so if we go not quite halfway around the other direction, we should land right below this, so our triangle is just flipping. Excuse my imperfect picture, they should line up exactly. Flipping upside down. So the y coordinate is now the opposite of what it was before, but the x coordinate is exactly the same. So it's a negative 5 over root 3, or negative root 5 over 3, negative 2/3. And that's at the end of a negative a arc length. We were supposed to figure out the value of secant. Secant is the reciprocal of cosine, so that's going to be a negative 3 over root 5. Okay, sine of pi over 2 plus a. As soon as the pi over 2's get in the mix, that's when you start getting the flips across y equals x, where your triangle is actually flopped x and y. So if we look at, hold on, what was it? Pi over 2 plus a. A was not quite halfway around, so here's pi over 2 plus a puts us down here. Okay, so let's see what's happened. We could think of it this way. We could rearrange our order, and we could think about it as a plus pi over 2. So a is right here, and here's the little triangle that goes with a. Pi over 2 rotates us a quarter of the way around the circle, so it's going to push this side down to here, and it's going to push the bottom down to the negative y-axis. So this length right here that was our y, 2/3, becomes our x and is also now negative. So this is negative 2/3. This negative root 5 over 3 that was our x becomes our y, and it is still negative, negative root 5 over 3. Okay, so those are the coordinates of the point we were supposed to find sine. So it looks like sine is the negative root 5 over 3. Cotangent of pi minus a. Oh, I might have used all my colors. I have a light pink. We'll see if it shows up enough. Pi minus a. So we start here at pi. We go back not quite halfway around, and we should end up right here. So let's see, pi minus a. Yeah, so it looks like our triangle is landing just like this. Which means our x coordinate is going to be the opposite of this point, so that's a positive root 5 over 3. Our y coordinate is going to be the same, and this was for an a value or a t value pi minus a. Pi minus a, put us there. Okay, we were looking for cotangent, which is an x over y. So I'll do my scratch work down here at the bottom. My x is root 5 over 3. Root 5 over 3. Our y is 2/3. Dividing by 2/3 is the same as multiplying by 3/2. So the 3's will cancel, and we get a root 5 over 2. Okay, very last one. My only color is yellow. This probably isn't going to go, but I'll start with it. The last one is a 3 pi over 2 minus a. So 3 pi over 2 puts us at the bottom of the circle. A is not quite halfway around, so we should be landing up here. Sort of working. You could also think about this as go minus a and then take this triangle and rotate it 1, 2, 3/4 of the way around. So your triangle is sitting up like this. So this What do we want to compare to? If we want to compare to that green one I just showed, this was an x-coordinate of negative root 5 over 3, and it's now become our y-coordinate, and it's positive. So our y is root 5 over 3. You kind of see it, root 5 over 3. And where's my green one? This little stretch right here was negative 2/3. That was my y. If I push that 3/4 of the way around, it becomes my x, and it's negative again. So negative 2/3 is my x. It's horrible to look at. I'll try and remember to bring home a little bit darker color. Okay, and we were looking for cosecant, which is the reciprocal of sine. Sine is the root 5 over 3, so this should be 3 over root 5. Legible? Oh, it's almost legible. 3 over root 5. All right, thanks for watching.